So in this problem, it's given here that we have a line 2x minus y plus 1 equals to 0 that is tangent to a given circle at the point 2, 5. And the center of that same circle lies on the line x plus y equals to 9. So using these information, we need to find out the equation of the circle. So let us begin. So here, let's try to understand the problem graphically first. We'll consider a circle and the line which is tangent to the circle at the point 2, 5. So here we have the circle centered at C, and we have a line with the equation 2x minus y plus 1 equals to 0, which is tangent to the circle at point, let's say point A, and the coordinates of point A is 2, 5. Now we have another line x plus y equals to 9, which passes through the center of the circle. And the equation of the line is also given to us, that's x plus y equals to 9. Now to find out the equation of the circle, we need two information. One is to find out the coordinates of the center of the circle, and we'll also need its radius. So let's try to figure out how to find out the coordinates of the center as well as the radius. Now clearly we have the line 2x minus y plus 1 which equals to 0. It is tangent to the circle at point A. If we can find out the equation of the normal at that same point A, then we know that the normal line is going to be perpendicular to the tangent line, and also it is going to pass through the center. Now clearly we have the normal line which is intersecting the line x plus y equals to 9. We can solve the two equations to find out the common intersection point, and that's going to give us the coordinate of the center. Okay, let us begin. So we will start with the equation of the tangent line. So equation of the tangent line that's given to us, we have 2x minus y plus 1 equals to 0. Now from this equation, let's do one thing. Let's rewrite it as y equals to 2x plus 1. Now if we compare this particular equation with the slope-intercept form, which is y equals to mx plus c, then our slope is going to be equals to 2. That's the slope of the tangent line. Now that we have the slope of the tangent line, we can easily find out the slope of the normal line. That's because the tangent line and the normal line are perpendicular to each other. If we call it m1, then it will be equals to negative the reciprocal of the slope of the tangent line. So this will be equals to negative 1/2. So we have the slope of the normal line, and the line is normal to the circle at the point 2, 5. Now to find out the equation of the normal line, we'll be using the point slope form, which is given by y minus y1 equals to m times x minus x1. M will be the slope, and x1, y1 will correspond to the point at which the line is normal to the circle. So in our case, x1, y1, that's 2, 5. That means our equation of the normal will be y minus y1. y1 will be 5 here. This will be equals to the slope, which is negative half, multiplied to x minus x1. So x1 will be 2 here. Let's solve this, or let's multiply throughout with 2. So we get 2y minus 10 equals to negative x plus 2. Rearranging, we are going to get x plus 2y equals to 12. So this is going to be the equation of the normal line. Let's keep it aside. Now what we'll do, we will solve this equation and the equation of the line which passes through the center, that's x plus y equals to 9. So we have the other equation, x plus y equals to 9. This is the equation that passes through the center of the circle. Let's solve it. What we'll do, we'll take equation 1, and from it we're going to subtract equation number 2. So that's going to give us y value equals to 3. Now that we have the value of y equals to 3, that means the x value will be equals to 9 minus y. So y replacing y with 3, we're going to get x equals to 6. So that means the point of intersection, the point of intersection of the two straight lines will be equals to 6, 3, and luckily this is nothing but the center, coordinates of the center of the circle. So now we have the coordinates of the center of the circle at 6, 3. Our next task will be to find out the radius. So if this is the center and this is the point of contact, CA is going to be the radius of the circle. Now we know the coordinates of point A, we have the coordinates of point C. Now we can use the distance formula to find out the radius of the circle. So CA which is nothing but the radius of the circle, can be obtained by using the distance formula. We'll take the square root. Underneath the square root, we need the square of the difference of the x coordinate. So that's 6 minus 2 whole squared. Added to the difference of the y coordinate, 3 minus 5 whole squared. So we get square root of, so 6 minus 2, that's 4. Squaring 4 gives us 16. 3 minus 5 will be negative 2. Squaring it gives us positive 4. That means the radius of the circle comes out to be square root of 20. So now we can easily find out the equation of the circle. Then the standard form of a circle is given by x minus h whole square plus y minus k whole square equals to the square of the radius. This is the standard form of a circle where h comma k, that's nothing but the coordinates of the center. So now h value, that is 6, k value is 3. So our equation will be x minus 6 whole square plus y minus 3 whole square equals to the square of the radius. So that will be 20. So this is going to be the required equation of the circle.